Hi, it's Gadget UK here again, back with another Commodore Power Supply repair. Now, I am not clued up, you'll know from the title, whether this is an Amiga Power Supply or something else, because it's narrow. I haven't seen an Amiga Power Supply like that before. It says Amiga Power Supply, 25 watts, 391029-02. So we've got 5 volts, 3 amp, 12 volts, 500 milliamps, minus 12 volts at 100 milliamps there. So, it says there A1200. So it must be an official A1200 power supply. Yeah, I've never seen one like that. And it's not the one that's got epoxy in it. It's, you know, a serviceable one. Well, I think it is. Someone's obviously been inside it, I think, because the warranty seal there is broken. So it says dead. I'm not even going to attempt to power it on. Let's just have a look inside first of all and see what state it's in. Now, safety disclaimer, if you've never worked on power supplies before, anything that's high voltage, when I say high voltage, I'm talking about, you know, over 9 or 10 or 12 volts, something like this. You know, you've got mains voltage. In the UK here we've got 240, 250 volts AC. I'm not sure what the exact standard is at the moment. Is it supposed to be 230 or is it 250? I don't know, it seems to change quite a bit. And it depends where you are, I think. God, that screw there's sort of pushing upwards, look, so it's, yeah, it's pushed the lid away. Straight away you can see that cap there is bulged. Not seeing anything toasted or incinerated. Oh, the fuse is missing. Well, you know, that's going to be a small problem, isn't it? Maybe there's not much wrong with this. The sleeving on that cap down there doesn't look so healthy. Anyway, I will just have a quick inspection of this off camera. We'll measure, we'll take this out actually, we'll measure to make sure there's no short on the mains, you know, the mains input site where it gets presumably rectified. I don't see a rectifier just now, but there probably is one, a bridge rectifier. And then we'll get a fuse in and see what it's doing. So there were 4 screws with a plastic washer in each, well, no, one in each corner. And we've got the board out there. Let's just try and flip it over. It can be quite hard working on these just because the blooming cables, you know, the cables put them on the desk might help. So just inspecting around the underside, being careful not to touch, you know, underneath of that main cap there. If you've had it plugged in recently and it's not discharged, that there could give you a shock. And of course you could just measure, you know, if you wanted to be safe when you're working on a power supply, any high DC capacitors on there, and that one will be. You could just, you know, put your meter on volts DC. Careful not to touch any of the connections. Just measure across that cap. You can see 0 volts. If there was a voltage there, you could use an isolated handle screwdriver or pliers and just short the 2 contacts together. It goes without saying, make sure it's not plugged in when you're working on it. And as I say, I take no responsibility for anybody electrocuting themselves working on a power supply. If you don't know what you're doing, you could hurt yourself, or very worst case scenario, kill yourself. A little bit of current, is it 20 microamps or something? You don't need much through your heart, and your heart will stop. So yeah, I mean, I'm not seeing any obvious things here, other than it perhaps needs, you know, that cap swapping out and one of the 2 of the little ones. That thing's a bit wobbly on that one. That's interesting, look how flaky those are. Well, that's springs. Yeah. Wow. Yeah, don't do as I do there, wobbling those like that. It's not very good, that, is it, really, in terms of its sensitivity to wobbling? You know, what's to stop that shorting something like that heatsink there when it wobbles? I don't know. Anyway, I guess you're not going to be dancing on top of your Amiga while you're using it. Unless you're Ravi, maybe. I'll inspect for bad solder points there, but let's just put the meter on continuity test here. And let's just measure across the main ballast cap here. Let's make sure we've got short there. So, yeah, the DC, you know, as it converts AC to DC through a bridge, we haven't got short there. Quite where the bridge is. Oh, it's down here. I was going to say quite where the bridge is, I'm not sure, but you can see down here we've got 4 discrete diodes. So yeah, that's where our bridge rectifier is. And of course you could just put your meter on diode test and just test each one of those diodes there. It makes it quite hard with this blooming wire. So I mean, I'll just do that, I'll just go across these just to make sure none of them are short. But we would measure that on the capacitor there, most likely. Yeah, that one's alright, that's 2. These need swapping around that way. Yeah, that one's alright. And the final one, and that's okay. So those diodes are alright, we haven't got any shorts there. We could do the same thing on the switching transistor here, so I think it's these 3 contacts here, so we could just measure across there. Just make sure we don't have any shorts. Yeah, so we don't have any reason why a fuse would have blown at this stage, because there are no shorts on the DC switching side. What this does, there'll be a PWM, a pulse width modulated signal fed into the base or some of this transistor here to give you a pulse, you know, high frequency pulse into this transformer. Yeah, and it's DC, like 380 volts or something, 370. It's basically 240 times 1.414 recurring if you're in the UK. If you're in the US, obviously 110 volts, it's going to be different. You can have a slightly lower DC there. But anyway, that high DC voltage is, like I say, pulsed into this, and then it gives you, you know, the transformer obviously steps down to give different voltages on the different windings there. For, you know, 5 volts, 12 volts, minus 12 volts. There might be some of the regulation or something on this side. We've got 2 diodes here. Those are usually used. There's 2 there as well to convert the AC out of this into DC, and then you've got an opto coupler here that isolates. You know, there'll be a isolation gap here. You can see this big gap between the middle of the board with some cutouts. Yeah, isolates the secondary side from the primary side here. And the PWM, the duty cycle, the frequency and duty cycle, probably the duty cycle of that is altered depending on the voltage levels. You know, so you've got some comparator sort of stuff going on around here probably. That might be the switching, I don't know, there might be an IC there for the switching to drive this, but there could also be some sort of comparator, so there will be a comparator circuit or something around here. There's, you know, what it does, the 5 volts, for example, affects this opto here, the level of it. And if the level goes too high or too low, it adjusts the duty cycle there just a little bit, one way or the other, to get the 5 volts just right. That's how a basic switch mode power supply works. So, yeah, other than the fuse missing, I don't know, I don't really see anything wrong. Anyway, I'll inspect on the underside, and then we'll get a fuse in, and we'll try it. I say no reason not to give this a try. So the fuse, it's marked on the PCB there. It says replace with a T 1 amp fuse only. The only one I've got, I'm not following the rules here, is a an F 1 amp. So this is a fast blow. So this may just blow. It might not prove anything. T is timed, or trage I think it's called, or something. Yeah, which means, you know, if you've got a massive inrush, it won't just blow. This may blow. What I can do is try 1.5 or something after that. But I see no shorts. We measured around the bridge down here, measured the transistor, measured the capacitor there, no issues. So the fuse, I think someone's took that out to fix another one. So it may be that there's nothing wrong with this. I don't know, I could have just looked out. If there is nothing wrong with it and it works, the one thing I would do is I would secure these things with a bit of hot glue somewhere down there, because wobbly like that, it's just crazy. I don't know. I don't like that. And I would swap that one. Swap this one down here, I think, and then just test it. So I'll leave you viewing it from there. I'm just going to make sure it's off. It is. And I'm just going to carefully plug this in. One of the things I don't like about some of these power supplies, the cable. Right, watch the fuse. Right, it hasn't blown. I'm about to switch it on. And it didn't blow, did it? Nope, still looks intact to me. So the next thing to do is measure voltages. I've gone straight to testing on this board. I haven't even measured from the pins because, you know, it's got a connector on here. We can just measure the voltages. Obviously, be careful. You know, something like this is isolated anyway. You know, it's got the primary and secondary isolated. But if I measure between ground and the 5 volt pin there, 5.1 volts. So the 5 volts is there. Let's just check on the plus and minus 12. So we'll go from a ground, we'll go for the, I don't know, the shield here maybe. And I think this is the, where's the op amp name? It's here. It's usually the middle pins, is it? Yeah, so we've got plus 12, pretty stable. And 11.4 is about right, that's what you tend to get on these. And minus 12, 11.4 again. So there we go, there's nothing wrong with that power supply. I looked out with that one, didn't I? But I will swap out that cap, I think, the main one, the main ballast cap. Right, I've ordered a replacement cap for that. But yeah, in the meantime, it's obviously going to be a few days. We'll just get this board out, we'll clean it up, we'll measure the ESR of the other caps and just see if any of those need replacing. We'll also, now it's been powered off for a few minutes here, but we'll just measure the DC voltage of that smoothing cap there. Yeah, now 0.7 of a volt. So yeah, safe to work on. So as I said, this is my first time seeing this particular model power supply. It's obviously not as good as the older ones. Those older A500 ones, like the one we looked at in the start of this video, is it provides more current. You know, more current on the 5 volt rate. It's like 4.5 amps, isn't it? This one's like 3. So whilst this might have been alright for an unmodified 1200, and maybe some of the slower accelerators might be fine with that, it's just cutting it a bit close. You know, you really want the 4.5 amp power supply in my mind. Certainly with something like a TF1260, but like with a TF1230 or, you know, something equivalent in 030, you might be alright with one of these power supplies. I think the one thing I would say is, because it's onto the smaller capacitors here, the same sort of size, like, well, these are a bit smaller, 1000 actually. I think I'd be more inclined to always recap this model, just based on the fact that these caps may have been super stressed, because they're packed in pretty closely there, and they're really small, you know, physically small, but also in capacitance as well. It's not like the 4.5 amp one where you've got 4,700 microfarad caps there. These are like 1,000 each, I think, or maybe 2,200. Let's have a look. No, it's 1,000. Yeah, 1,000. I think those two are 1,000. So yeah, I would be replacing those caps, I think, as well. Even though I said I was only going to do that one, I think we'll take them off it and certainly check them. Might just measure them in circuit and see if there's any ESR problems. So this one, as you can see, is pretty blooming yellowed. It's the heavy brick version. This weighs an absolute ton, so it's going to have a giant transformer inside there. You can, oh hang on, C128. Ah, that's interesting. So I've got a power supply for a C128. It's not an Amiga. 5 volts, 2.5 amp, 9 volts AC, 1 amp. That's fused, 1.4 amp. And input fuse there as well. So there's 2 fuses, 315 milliamps. So yeah, it weighs a ton. So anyway, this might be the start of the C128 series. I don't know. You can see the first thing is it's missing plug, so I'm going to get a plug on there, but before I power it on, I will be taking the lid off. We'll have a look inside, just see what state it's in internally. It's got the same connector here as an Amiga, but well, I think so. It looks a bit mangled, maybe. I'm not sure if that's had it's had some sort of impact here, so that might be part of the issue with that, but we could always somehow try and manipulate that with pliers to straighten that a little bit. Anyway, let's get a plug on. Yeah, so don't take this as any kind of guide or tutorial, although that's what it's marked as. That's got 13 amp fuse there. Let's get rid of that. You want a 3 amp fuse in something like this. Yeah, and this plug, yeah, it might not be the latest in terms of screws just fart. Yeah, it might not be the latest safety standard, you know, safety approved standard here in the UK. I don't know. Things are changing all the time, but this is just a plug I've had. It's a British standards one. It's marks there with the kite symbol and stuff, and it probably says something on it somewhere which British standard it adheres. So I've just dropped the thing again. I tell you what, it never gets old dropping things on this floor. Now I have floor instead of being on the floor. I'm constantly dropping things on the floor. Anyway, yeah, so in the UK here, your live goes there, it's brown. Your neutral goes here, and it's marked LN on the actual white plastic there. Yeah, your neutral here, and then your earth is the green and yellow. And the earth should always be longest. And the reason being is if this cable relief here was not tight and you were to pull it out, in order of length you want the live the shortest, the neutral slightly longer, and then the earth the longest. The idea being that the live will pop straight out, the neutral may then still be attached and then will pop out, and the final thing to pop out will be the earth. You always want your earth to be connected no matter what. So yeah, I'm not going to just stick those in. I think what I'm going to do is just trim back a tiny bit here, you know, the length of the cable almost. So I'm just going to just snip out carefully here. This isn't the right tool. You can get proper tools to do this without marking or scoring the internal cables. You've got to be careful. But anyway, if we just do that, score all the way around carefully, and then pull that away there. That's it. And now that's gone on the floor. Everything goes on the floor. So yeah, what we can do now, you see, is just trim off. I'll do this onto the table. Just trim off that point there, and we'll just, you know, peel them back freshly. Just because those have probably been twisted and manipulated and stuff in the plug that was on there previously. Yeah, so if we just simply, you know, just do the same thing there on each one of those little distance, we can just screw them in there, make sure they're nice and tight, get a 3 amp fuse in. I'll report back in a minute. You can see I've got the live in place, and I can sort of push that fuse in. Yeah, I'm not happy with the way the live is positioned there, that terminal. Yeah, it should be alright. It just needs to go, there we go, over that little piece of plastic there. So yeah, it's pretty tight that. Is the neutral going to reach down here? I don't know if this is the problem. What I might need to just do here, actually, just because the live's a wee bit tight, and the neutral too, seemingly, is use the right screwdriver. Just loosen off the cable grip here. So yeah, there we go. It's a wee bit tight in there, but that should do. Yeah, the fuse is alright. I don't like the way this is sitting here, but I think that's just this plug. I'm accepting the risks here of going with this older plug, but it was British approved 15 years ago. There we go. Right, shall we switch it on? So the interesting thing with this behemoth of a power supply, there's no switch on it, so it's just always on. So yeah, I think we'll plug it in, we'll just measure the voltages. I've just got this sneaky feeling this is just going to work again. Why someone would pull the plug off that, I don't know. Because obviously it's a useful power supply. There can't be that many C128 power supplies around still. Right, I'm going to plug it in. Will it strip the mains? And the answer is no, it didn't. So let's measure the voltages. Well, surprisingly, the first combination of measures, we've got 5 volts. Use a piece of plastic tube in here. Yeah, between that pin and the bottom right pin, we've got 5 volts DC. Now we've got AC on this, haven't we? So if I switch to AC, I'm guessing the AC must be a combination of these, one of these 3 pins to the left. I've got 3.3 volts there. 12 volts AC there. But if I measure between the two on the left hand side there, you can see we've got 12 volts AC. And it's pretty much spot on, so I actually think this power supply works. It's yet another faulty power supply that's got nothing wrong with it other than a missing fuse or a plug. It's really strange as to what's happened to this, to be honest. One thing I've just noticed is I just squared this off. I strained up the top there. When I say squared this off, I don't mean the centre part, because that's supposed to recess a bit there, and it just needs a bit more here. It just needs like a slight twist that way. Yeah, that's pretty square. And I guess unsurprisingly it's the same as an Amiga connector here. So if we plug this in here, you'll see it goes straight in, no worries. But watch what happens when we pull it out. If we pull it by the sleeve in, it's coming off. Yeah, you can see that. So that's loose, so if we just disconnect it, somebody's obviously been tinkering here because that's a bit slightly damaged there. You can pull that off. Yeah, this all looks untouched. Yeah, that looks factory to me. This has been down here, so someone has been messing, and that's perhaps the part that catches. It isn't though, is it? I don't know. Let's just see. Yeah, I think that catches there. This needs lifting up. So for whatever reason, someone's been inside it, but there doesn't appear to be anything wrong with it. So I think I just need to manipulate this for some pliers now to straighten this out somewhat, if we can. Just raise it up, and then it might grip. Oh, hang on, I'm pulling the thing to pieces here. Anyway, I'll report back in a minute when I've got that sorted. Right, a few seconds later, you can see that that's pretty level now. So I think we'll try and connect it that way up. Yeah, it's got to be that way, because there's nothing to correspond with that on this side here. It's just smooth. So I think someone's been in that for one reason or another. Oh look, it clipped. There you go. So we've now fixed that. When you get little bits of plastic like that stick out, I've shown this technique before, just press over an angle like that. with a smooth round edge. That's gone back in. It looks almost like no one has. It looks almost like no one has tinkered with that. Just pressing. There we go. That's it. No one would ever know. So that's all back together. What we do know is the connectivity in there is good. I'll get some contact cleaner in there next. We'll clean that up with some cotton buds. I mean, these C128 power supplies, they must be an endangered species, because in general there aren't that many C128s around. I'm not sure how many Commodore sold. I might hit Wikipedia to find that out. But yeah, I've shown this before. You can just use a cotton bud like this, and it works better if you scrunch it down like that. Let's just get some more contact cleaner. It's probably running evaporate by now. Yeah, you can see there is a bit of a gap here in the shield. But anyway, let's just go a few different angles here. Well, all different angles around these pins. Yeah, that's it. That is pretty much good as new in there, I think. Yeah, and as you can see, that's pretty square. You know, it's a little bit marked here, but it goes in perfectly into the Amiga motherboard. Incidentally, when I plugged it into that Amiga motherboard, it wasn't powered up, because the last thing you want is AC going onto one of the supply rails on an Amiga. So it's another one of those knee repairs, this, isn't it? To get inside this, it looks like there's no screws. It's deceptive. This is like a little plastic bung here. So you've got to get like something really fine, like a, I don't know, a blade. Let's use a blade from a knife maybe. Or a pin. And if you get right onto the very edge there, you may be able to try and lift it. It's easier said than done. Right, I got one of those out, and you can see I made a mess of it on the edge of it. Barely marked the edge there, but still, they're cheesing me off that much. I've just screwed a self-tapping screw in. Hopefully that's deep enough, and then we can just pull it out like that. So yeah, because you're not going to put them back in. That looks just no different now than any other Amiga power supply where you can see the screw holes. It's more serviceable, so I wouldn't stick those bungs back in anyway. There's just no point to it. So yeah, I'll show you on the next one. This will just, you know, this one here, I've been struggling with this one as well. So let's just screw it in, go down a number of turns like that, and then just pull it out. Easy. 4 screws of ridiculous length, all the same length. Yeah, the temptation with this was to just leave it as it was and clean it up, but look, look how much dust and fluff is inside that. So yeah, and obviously you can tell it must be one of the very early power supplies here. Well, when I say that, it's not an Amiga one, is it? I was thinking of the Amiga, but yeah, like these caps here, like are older ones, aren't they? But you see the C128 did precede the Amiga. Got an interesting piece of wire here, see that? I don't know what that is. Just like a large extended piece of wire. Anyway, we need to vacuum that, use some cotton buds with some IPA to get all the dust and fluff out of it. It seems like there's 2 capacitors there. We've got I think that's a 4700, is it 6 volts? And we've got a 2200 there. So I may as well recap this while I'm here as well. 3.15 amp fuse, T, timed again. But yeah, there's going to be not much to do other than just inspect for dry solder joints and things under the underside there, and swap those 2 caps. Right, and now just get it out. There's going to be a screw or 2 holding that, and I can see one down there. Yeah, these might be ones, yeah, these are ones that go right through, look. They go right down. Obviously we've not got all the dust out of the way there, and just get right down to the board. So yeah, these are different ones to the other ones. That one's a wee bit corroded actually. Ugh, that's dirty. Hopefully this should now come out. Yeah, there we go. Put that on the bench. So no mains rated electrolytics on there. It's literally probably just the mains going straight into that. I would imagine it's not going to be particularly efficient, this, because it doesn't look switch mode to me. I think we've just got some linear regulation going on perhaps. That could be a transistor. It could also be an SCR. Still don't know what these huge wire links are down here. That's where the mains goes in, isn't it? So there is a bridge, I think. Yeah, because this is the mains fuse. There we've got 4 diodes, so that's going to be the bridge rectifier. So maybe it is switch mode, I don't know. There's no mains rated electrolytic there. Well, none that I can see. Anyway, I'm just going to collect up all the fluff and dust bunnies and stuff. Not sure what this is, a choke maybe. Ah, the mains comes in here, so that's actually the output. So, oh, I don't know, I think that's a bridge. Yeah, that's not a bridge for the mains. That's a bridge for the 5 volts DC, isn't it? So yeah, the mains comes in here. Got a choke, I think, and a capacitor. Is an X class or Y class cap there. A few actually here. The fuse straight into the transformer. So it's, yeah, 240. That's why it's a big transformer. 240 volts going in, stepping down to give us 12 volts AC, and just more than 5 volts, probably 8 or 9 volts for potentially a 7805 or something here. It's really blooming simple, this power supply. Incredibly simple. There's so little on it. The only thing I'm not sure about is exactly how they're doing the 5 volt regulation here. But it's going to be this IC here and these 3 semiconductors, because the AC obviously is easy to just pass straight from the transformer, and that's what the bridge is for here and stuff, and the fuse is all for the 5 volt side, I think. And obviously there's a few transistors, there may even be an SCR or something there. But, you know, nice big chokes and things like that, nice big inductors. Obviously it's got a choke and X and Y class caps and stuff on the input side there as well. The board's dirty, so I need to clean this up and solder any dry solder points. That is filthy, actually. And you've got to be careful with this, because the weight of that transformer, yeah, there could be some dry joints here, but you could break the PCB really easily with this. So I'm just being careful how I position this. I'm going to clean around with cotton buds now, and then we're just going to get those 2 caps off. We'll measure them, see if they need swapping out. I have no idea at the brand. I've never seen that style of cap. It's an old design, it's an old style. So anybody's guess, are they going to be good, are they going to be bad? I don't know. And I'm guessing they're both actually for the 5 volt rail, because the AC, you won't have a capacitor on it, that's for sure. I think there's a 2200 40 volts, and I think that's like the input to the 5 volt regulation, if you like. It might be as high as 30 volts or something there, I hope not. But then again, it's not done with a 7805. I mean, the sorts of faults you get back in the day is a faulty bridge, you know, one of the diodes would fail, fuse would go, or a faulty switching transistor, again, fuse would go. So it would be completely dead, and then you'd find there's a short on the switching transistor, and 99 times out of 100 that's all you'd ever get. There'd be simple fixes like that. Sometimes you just get a fuse having blown for no real reason. There'd be no clue. You'd change the fuse and test it for hours and hours, it'd be fine, and then it would be in operation again for years and never return. I had one of those with my TV, actually, my LCD TV, the Philips. About 18 months ago, a fuse went on that, and I was panicking, thinking maybe something had gone wrong with it, and changed the fuse, and it's been alright ever since. So I don't know, maybe the caps on that are on the way out. That could be a clue that that's the problem there. Again, I am not going to make this like a Picasso, like super clean and, you know, presentable here. We're just going to focus on where all these funny marks are like that there, and any flux. Flux, in some cases, can become conductive. Some of the older types of flux I've seen create conductivity between places you don't want. So yeah, I always try and wash this off, where certainly on power supplies and things, wherever I see it now. There's a huge blob of solder there, look. I think we'll have a look at whatever that is in a minute on the underside. I'm not sure what of these marks are left from manufacturer versus just, I don't know where it's been. You know, this could have been another one that's been dumped into a skip, and it may be a bit, you know, weathered from rain and what have you. So that might be what one or two of the marks were on this. There's like that around there, and around here, look, there's some strange little marks. Right, so I took that capacitor out as well. It was showing just over 2,200 microfarad and 0.01 on the SR. There's no problem with either of those, so I just reinstalled them. I'm not going to sell this. I'll probably keep this as something for a C128 if I get one. Yeah, so other than well, reassembly, I think. There's not much more to do. I'll clean the cables up and stuff. We'll clean the shell up. Obviously, you need to get the fluff and dust out of there and off that black piece. But yeah, I'll perhaps just jump to a conclusion of showing you this reassembled and all cleaned up. But if you pick one of these up, you could just swap those caps. Right, the yellow in here actually is a combination of the normal yellowing and environmental dirt and stuff. You can see there, can you see in the light? That looks terrible. Look at that. And as of white tea, you can see streaks. Some of the yellowing's come off. The paper towel's gone all yellow, look. That shows you that it's a combination. It's two things. So yeah, I've ordered some Vanish Oxy Action. I'm going to soak this in some boiling water with some of that for 20 minutes, and hopefully a majority of this will come off. It may still be a bit yellow, but it won't look like that. I mean, look at the Commodore logo. There's stuff growing in there, I'm sure. Yeah, so we'll soak that. And I'll give this another go with the cotton buds here. But yeah, I'm not going to do anything else to this at this stage, just reassemble it. So I wiped all that crusty stuff off that. Yeah, it was like covered in it, wasn't it? And the screws, you know, you can see the heads on them. They're awful. So yeah, some liquid or something's got into that at some point and just landed there. Anyway, that should be good enough to go back in, I think. Do the same with that one. Look how much cleaner that is. It's incredible. Yeah, just soaked it in a bit of Vanish. So it's still yellowed a little bit. But yeah, after that's been in the sunlight for a little bit of time, in spring, you know, we get more sunlight here in the UK, it'll de-yellow and be almost back to, you know, its normal cream colour. You can see the difference on the inside there. So it's still yellowed, but there's such a difference there. It's like a night and day. It really is. It looks so much more presentable. So other things you could do, you could drill out the rivets here and replace with you know, a nut and bolts and put new thermal compound, but everything's alright here. So yeah, I've just got it back into the case. I'll clean up the wires in a minute. Yeah, and we just need to get this in here. It's got a little notch that sticks out there, actually, that just corresponds, you know, it isolates the heatsink here, just keeps it away. Why is that not going down there? There we go. And there was one screw holding the board in down here in the middle. Right, so yeah, those screws are really, really weathered. But anyway, you saw me clean them up. I'm going to swap them around so that the less corroded one is where the really corroded one was previously. I mean, I can see the comments now. What? You went in there and didn't replace those caps? There's nothing wrong with them. There's absolutely nothing wrong with them. I actually suspect it's probably not had masses of use, this power supply. I know it looks, you know, dirty and battered and stuff, but yeah, I suspect it's not had much use. That's it. Make sure those are nice and tight. And yeah, and it needs some UV, obviously. Either retro bright or just sun brine. I will just stick this out in the sun when it gets a bit sunny. I've done that with that's happened unintentionally with a number of Amiga power supplies I had in the conservatory, actually. Just because they're in there in sunny weather. They're all de-yellowed, they look brand new. They look absolutely brand new. We didn't do anything to them, didn't put anything on them, no chemicals, no nothing. So yeah, you don't always have to do retro brine, and in fact I would go to sun brine before retro brine. Which is not something I thought I'd ever hear myself saying, but you know what? It's the reason why so many things get yellow. Actually, I think it's because they've had no sun. Nearly every single thing I put back into a box in a dark room goes yellow, whether it's sun brighted or retro brighted or what. So yeah, it's lack of light that causes the yellowing. There may be instances out there where the sun causes the yellowing, but I keep seeing the exact opposite. And finally, I just need to clean the cable. So yeah, I've shown this before, just like try and hold the power supply down, perhaps with the foot gently, and do a little bit of this with some IPA. And you can see, look at the dirt coming off that, that's incredible. Now, magic erasers I always try and steer clear of, but look how well that has worked. I couldn't get that dirt off. Yeah, just put some IPA onto a magic eraser, What I wouldn't do is use this on a plastic of a system, because it's well, it makes it go all matte. It makes all, you know, you remove any glossiness, you remove any marks, but you also remove print, and it marks the surface. So yeah, don't use a magic eraser for anything other than something like this, really. But it works really well on this cable. I'm shifting the dirt with no effort here. Right, the final thing for this, power supply is contact cleaner in there. I can't remember whether I've done this. I don't think I have. Maybe I did. Maybe I did this earlier. So we may revisit this power supply. Yeah, I've stuck a label on there, C128, just so I don't accidentally assume that's an Amiga power supply. Yeah, it's outputting just around 11 volts AC, not 12, so it's a little bit shy, and the 5 volts is spot on 5 volts. So is there a problem with this? I don't know. What we do know is it's nice and clean inside. There's no dry joints. The capacitors, the two capacitors, are okay. I don't see any faults or anything, you know, nothing visibly faulty. So yeah, this may be a revisit, and if we get a C128, we'll be using this power supply, see if we can power it. But anyway, you can see it's come out looking pretty much like pristine. I'm not going to put those bungs back in. I made holes in them anyway when I unscrewed them, but yeah, it's easier to get into now anyway. So my replacement caps have arrived. It's just an M-class CE Panasonic 33 microfarad 400 volt. I'm going to swap that for no other reason, well, then this is more modern. You can see it's half the size there for the same rated components. I'm not sure if this is 105 degrees, but yeah, just because the sleeving's a bit stressed on that. And it's a switch mode power supply, so you know what, it's always a good idea generally to swap that one. But I will test the others with the ESR meter there, and there are some pretty weedy ones down here, and these ones here, they kind of look like the same brand. I've seen leak before, so yeah, I will check them. Maybe they're not actually. They look a bit Nichiconish, don't they? And Neo Geos, they look very similar to those with the brown colour and the white print there, so I'll check them anyway. But at the very least, I'm just going to swap that one, and then we'll do some testing on it to see how it performs. If you do service a power supply, it's very important to be open and honest about exactly what you've done. So I wouldn't sell this and say, fully recapped, when I'm replacing a single cap. I would advertise it as such, you know, that I've replaced a single main ballast cap. Maybe even point out the size of it, you know, 33 microfarad 400 volt. Single-sided these. I'm just trying to straighten that leg somewhat on that one. That's it. So the ground is towards the top here. There's probably a wee bit of solder holding that. That's it. So yeah, that's out. Just good measure. I should have done this before I removed it, just to show the legs there. Yeah, we'll measure that in a minute. So it's 400 volts, 33 microfarad. Yeah, it is 105 degrees C. I'm not sure on the brand, I think it's KME, whoever they are. Anyway, let's get any Panasonic in. So, yeah, ground towards the top. Wow, it's a good job I checked that. There's no markings on this. There's no markings on the PCB there. Yeah, no markings on the PCB for polarity there. So, yeah, it's a good job I checked that, isn't it? I'm just going to review the camcorder footage in a minute to make sure it is ground towards the top. I'm pretty sure I said it was. And let's solder that on. We'll trim that down, and I'm going to have a clean on the underside of that PCB as well in general, because it is a wee bit dirty, you can see that. And I'll inspect for dry joints, but I think we did that before. Anyway, yeah, it's on, ground towards the top. I'll just confirm that is how the other one was fitted. And as you can see, I'm cleaning where I've not soldered here. This is original factory flux around the isolation section here. So it's always a good idea to get this stuff off. Sometimes, as I said I think in the previous videos here, it can become conductive, some of this old crusty flux. And you know, it leads a path, doesn't it? If you've got some in the middle here, if this area is not super clean, you've got a path between the primary and secondary if you're not careful. But 99 times out of 100, even more than that, 999 times out of 1,000, you won't have a problem with flux. but I have seen flux become a problem. And of course it's just easier to see what's going on when you've not got all this flux on every other solder point around here. Right, we're pretty cleaned up here. You know, I don't like these. I don't like springs look. I don't like that. It's subject to vibration. There's a heatsink here with this diode on, this rectifier. Look, here you knock your desk, you know, anybody's guess what happens if that was to short there. I think what I'm going to do is just get some tubes of heat shrink and just put some tubes of heat shrink and just shrink them down a bit. And you could think that's a bad idea, but you know what? Inductors are often just encapsulated in plastic and stuff anyway. The stress that these are under is not immense. These aren't going to get hot, but I would feel happier knowing that these aren't going to spring around with slight vibrations and knocks because the heat shrink will hold them, but also it's not going to short here and stuff. I mean, look at that, that's ridiculous. What effect is that on your power supply line when that happens, when you knock it with your foot under the table when it's running? Yeah, so post your thoughts down below. Do you think I'm crazy? I don't think so, because I think these are going to be more structurally secure now. There's a gap for air, you know, heat to get out on the top here, yeah, but also it's protected from wobbles, vibrations, touching or shorting onto anything should, I don't know, some of the enamel come off, or, see what I mean? I just think there are a number of reasons why this is perhaps a good idea. Doesn't need to be super tight around that, does it? Of course, if you've got the heat shrink too small and too tight here, it could squash it inwards. Not going very high on the heat here, just over 100 degrees-ish really, 150-ish. I mean, you could secure those further by putting a little bit of hot melt glue at the base of them now, because with the rigidity around them, that would stop them from twanging at all. So you can still see they still twang a bit. So the other one I will swap out is the one here, ground towards the right. The ones on the output side, everything looks alright, everything does measure alright. One of them, I had to desolder one of the pins to measure it, because it's obviously in the circuit. But as you can see there, 1.1 ohm, and it's just given a single ding. Yeah, 1.28 ohms. So if I just compare to a brand new 47, and if we look at the difference here, look at that 0.22. So yeah, I will swap that out. And I'm not sure if it shows you the main cap there, almost 33 microfarads, so it's a bit under 0.7. So just test that again, get a couple of averages. 0.84. Yeah, so 0.84 again. 0.84, I mean it's giving 2 dings, so yeah, you could argue that's alright. But the new Panasonic, and bear in mind these are not super low ESR ones, yeah, they're about the same. So the ones we're replacing here, this is the thing, this is a point. So you could argue that's not as good as the one that was on there, 0.93. The capacitance again is a bit lower, so yeah, you know what, you don't always need to replace every single cap on every single thing you come across. And that old cap will go into my post-apocalypse bag of caps here, because you know what, like 99% of those are good. It's always handy to have something like that, in case you can't source a capacitor. So the next thing I'll do is peel that label off there and get this into the sink. A little bit of vanish oxy action, I think. I mean, it's pretty good condition already, it's pretty clean. There is some yellowing up here, but anyway, we'll clean that up. So the case is soaking in some TAED, you know, so Vanish is the brand name here in the UK and probably in Europe. Because we can, and it's, well, I say we can, it's not that easy to access that. And I'm going to get some new thermal paste on, because that's gone all dried and crusty. You notice the isolation tab here, plastic isolation tab in the front, so yeah, pay attention to things like that. But it's not isolating the transistor back, the transistor base there, I don't know if you can see that if I just tilt this up, it's actually making connection with the heatsink. But anyway, we'll just pull that forward. I'll get some cotton bud with IPA, clean that up. I mean, there's literally nothing on that. There's no thermal compound left. It's just gone crusty. A clean around that. Try and get right down there. We'll just squash the end of the cotton bud so I can get right into the gap at the bottom. Servicol heatsink compound here. I found this tube in my storage. Actually, it's unopened though. Yeah, I've got a few of these. Let me just go and find the other ones. Hang on. I'll apply it with a cotton bud, I think. It's probably not the best thing because you're going to get fibres there if you're not careful. And I've probably got way more than I actually need, but nevertheless we'll get some all around that. Final thing is to get the screw through there and align it all back up here. It's going to be a bit fiddly to get this in, isn't it? Now it might be easier just to tighten the nut with some pliers rather than try and fight with the screw. That's it, that's nice and tight. So we can just clean the excess off. Right, that'll do. So I did just have to unscrew that again because there was a washer on the back. It'd fallen onto the PCB down here. So yeah, you generally will have a washer. Because we've just, you know, bent the whole assembly left, right, a little bit there, once or twice. Not much. I'm just going to reflow the transistor legs there. This is a good idea because they've been subjected to a wee bit of physical movement. And then I'll just clean around with cotton buds and IPA again. Best way to do it is to desolder it before you do that, and then you won't stress the legs out, you won't stress the solder points out. Yeah, I put a red dot there, and for the eagle-eyed, these had red dots on from factory. I've wiped them off, so yeah, all the other caps are still stock, all the stuff on the secondary side there. Just written some dodgy red ink there, primary recapped 2022. Right, so all cleaned up and dried. Sticky label came straight off with that vanish oxy action there. It's in pretty good condition really. There's barely even any yellowing, just a bit here on this side. So it's another one of those where I'll probably get this out in the sun. There's a tiny bit of moisture there, look, just give it a swing like that. I have just had hot air on this, so yeah, it's just literally a tiny drip left. So yeah, the labels are still intact here and stuff as well. And along with our broken warranty seal. Anyway, let's get this back in to there now. So I think, yeah, it goes this way because we've got power switch and mains cable there. One, two, three, 4 screws. It's interesting the 2 screws are around the power switch. There isn't one in this bottom corner here, but it is of course held in this corner by the lid. So yeah, just get the lid on there, flip it upside down. You could argue test it before you commit to completely screwing it back together. If you're servicing power supplies yourself, just bear in mind, let's say, safety implications and stuff. Make sure it's always properly fused. You've got a properly rated safety, a plug that's up to safety standards. And maybe consider warranty sealing yourself. Well, not yourself, but warranty sealing the product, do you know what I mean? Yeah, so like, if I was to sell this, I would stick a warranty seal over there, I think. So I haven't tested it on a 500 yet, so I'll test it on the 500 in a minute, but you know what, I'm so confident I'm going to clean up the cable in advance, so it's not too dirty, this one. There's a little bit of dirt on there. Right, the cable's all cleaned up. Let's just get some contact cleaner in there. Just wash one end of the cotton bud down. Try with the large, the wide one first, just to get right in, because you can actually get it in between the pins, rotate it a little bit. And they're so sturdy, these pins, as long as you don't force it, you won't bend them out of position. Right, I can't get down the middle there of those top 2, because they're a wee bit close to each other. But you can see some of the dirt coming off, then use the squashed end, and then generally you'll be able to get right into the corners like that. Wow, some black marks coming off that. Look at that. So I've got that Scandinavian A500 that you may or may not have seen yet. Link will be top right once that video's up. Switch it on. And you can see it's working. And I think that's loading June as usual. Anyway, that's 3 power supplies repaired in this video. That's not too bad. They were like, worked out literally about £1 or 2 each. It's incredible how cheap some of these faulty power supplies are. So no real faults with these particular ones. I looked out with these ones. 2 more or 3 more, I think, in the next video coming up. We've got, you know, some more complex faults, different faults, etc. And all different models. So if anything, it was interesting to see the different models here. But all those PSUs were tested for like 12 hours each. I did load testing on them. See previous videos if you want, you know, to understand really how to use Ohm's law to calculate resistor size and draw a specific amount of current. A good example is the A2000 PSU I did recently. There'll be a link top right to that. And you should perhaps use an oscilloscope to measure any AC ripple on the different supply lines there. We'll have a look at that in the next video. And you can see the little pile of power supplies here, and there were a number more by the time I actually get to the end point of finishing look at these power supplies. I've still got 3 or 4 more still to look at. We've got quite a few different ones coming up with different faults and stuff. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.